Let me show you a couple of problems that show up. Similar questions will show up on an assignment I'm about to give you. I'll read through this with you because it's my scratchy handwriting. A man 5 feet tall looks into a mirror, that mirror's on the ground, and sees the top of a monument. The man is 8 feet from the mirror, and the mirror is 60 feet from the monument. Make a sketch and find the height of that monument. What would a sketch of that look like? And I'm going to build such a sketch right here. We're going to look at some similar triangles and work this right out. Here's such a sketch. Let me put some of this data in here. So the man is 5 feet tall. We'll call that distance 5 feet right there. The height of that man. And he looks into this mirror, and there's the mirror right there. And he sees the reflection of the top of this tall edifice over here, this monument. The man is 8 feet from the mirror. So let's let that distance be 8 right there. And the mirror is 60 feet from the monument. Right there, that distance would have to be 60. And we wish we knew how tall this monument is. I'm going to call it M for monument. And a couple things we want to think about. Are these triangles similar? And I'm thinking that they would be, and we could think that the monument is perpendicular to the ground and the man stands straight up to be that 5 feet tall, and that's also going to be perpendicular. And interestingly, when light strikes a mirror, this is called the angle of incidence, and this is the angle of reflection. Those are going to be congruent as well. So I got two angles in this triangle congruent to 2 angles in that triangle, so I got similar triangles. And I can use that to write a proportion. And pretty quick and easy. The height of that man 5 is to his distance from that mirror 8. Now I got to finish this proportion over here. You can stop this video and you think about what's going to happen there. But I'm thinking opposite these congruent angles, this 5 is going to go with that side of length M is to this lower length 60. So that's all I got to do is figure out this little proportion right there. And 8M is equal to 5 times 60, there's 300. So I've got to divide both sides by 8. Hey Alexa, what's 300 divided by 8?
300 divided by 8 is 37.5.
37.5 feet tall. That'd be the height of our monument. I got another one, perhaps a little bit more interesting, before I cut you loose. Joe sees that his shadow coincides with the shadow of a flagpole. Joe is 6 feet tall, and Joe's shadow is 20 feet long at a certain time of day. Joe's 100 feet from that flagpole. How tall will that flagpole have to be? I'm going to make such a sketch. So here's the flagpole, and there's Joe. And we're thinking the sun is somewhere over here, and the rays of the sun come across that flagpole and come across Joe at the same place. And here's the shadow that Joe casts. And that is also where the shadow of the flagpole terminates. I'm going to put in the data that we know about. I know that Joe was 6 feet tall. And Joe casts a shadow that's 20 feet long. And Joe is 100 feet from that flagpole. So this distance has to be 100 feet right there. And we wish we knew the height of that flagpole. We're going to call it F. Looking for similar triangles, and I think I got a pair. I know that this guy's standing straight up, so that's a right angle, and the flagpole would be perpendicular as well. And they both have this angle. So 2 angles in this small triangle could go to 2 angles in the bigger triangle, so I do have similar triangles. And I got to just write some kind of proportion to find the height of that flagpole. Let's see what we can do there. I'm thinking the height of the man 6 is to the length of his shadow 20. As the height of that flagpole, F, is to the length of its shadow, which has to be 120, doesn't it? If you had used any other proportion, I'm not sure you'd get it right. The height of the man is to the length of his shadow, as the height of that flagpole is to the length of its full shadow. That would have been 120 feet. So, as we cross multiply here, 6 times 120, 720 feet there, should equal to 20 times F. Looking for the height of that flagpole, dividing both sides by 20. Yeah, I'm thinking that the height of the flagpole, F, knock a 0 off each of those, and 72 divided by 2 is 36. 36 feet tall. That would have been the height of the flagpole. Let me cut you loose with about 5 questions similar to this, and we'll be back in touch, and that'll be a good thing for you to work through.